Okay, today we're just doing a couple practice problems on how to write half reactions, and that's really it for today. Probably 10 minutes, maybe 15. Here we go. All right, the first thing you need to identify is what's being oxidized, what's being reduced. I just want the half reactions, and so you're only going to concern yourself with what's being oxidized, what's being reduced. I'll give you a moment to identify what is being oxidized, what is being reduced. If you're wondering what SB is, that is antimony. It's a metal. All right, I'm going to start going over what is, I'm just going to write in the numbers. Hopefully yours will correspond. Oops. All right, there's my oxidation numbers. See if yours match up. David, what is being oxidized? Antimony is correct. And Kayla, what is being reduced? Nitrogen is correct. All right, so we only need to concern ourselves with these two. So it looks like antimony went from 0 to +3. So it lost 3 electrons. And nitrogen went from +5 to +2. So it gained 3 electrons. I think you guys are going to luck out with this one. It's already going to be balanced. So you just need to write the half reaction now. Whenever electrons are lost, those are going to be represented as products. So here we go. There's the oxidation half reaction. I want you to notice that the electrons are products. And there is the the reduction half reaction, the electrons are the reactants. There's no balancing needed because the amount of electrons on both half reactions is 3. So it is already balanced. That one you lucked out on. Any questions? Yes, Francis. Yes, thank you for catching that little typo. Anything else? All right, let's do the second one. Here we go. All right, guys, I am going to let you go for it all. Do it all. Give you about 2 or 3 minutes. That should be enough time. I know there is no oxygen on the product side. Consider it to be a non-factor. No change. Ooh. Anybody here a Bucks fan? They just re-signed Antonio Brown. Well, I guess that's everybody. I don't know where they keep getting all this money. All right, let's see what we have here. It looks like iron goes from +2 to +3, so it loses 1 electron. So iron has been oxidized. And manganese, well, let's see. That's manganese, by the way, not magnesium. Let's see, 4, -8. Manganese is, you guys get +7. Okay, it goes from +7 to +2. So that means that it got reduced. So we have that figured out. Let's go ahead and work this out. Iron lost 1 electron, so it's going to be Fe +2. It's going to become Fe +3, or iron 3, plus 1 electron. Remember, this is unbalanced. I'll balance it momentarily. And then we have manganese, another metal. It's at +7. It went from +7 to +2, so it gained 5 electrons to go up to Me +2. Is this one balanced? No. We need to get the electrons balanced. Okay, we have 5, we have 1. So what do we need to get which one should we change? Arshan? Yeah. How many electrons should I replace the 1 electron with? All right, we're going to replace that with 5 electrons. And so, Arshan, how many irons will we need? We need 5 for each. Each iron will lose 1 electron. There are 5 electrons being lost, so 1, 2, 3, 4, 5. Each of them will lose 1 electron, so we have 5 total. Those are the balanced equations. To prove that they're balanced, you have 5 electrons on the oxidation half reaction. You have 5 electrons on the reduction half reaction. Yes? Where I got the what? Okay, so here's MnO4 with a -1 charge. That means the sum of both of them must be equal to -1. Okay? So oxygen is always going to be -2, or most of the time will be -2. There are 4 oxygens, Kayla, so what's -2 times 4? So that means that manganese must be +7 in order for that to be -8, for the sum to be -1. You got it? Okay. Okay, are there any other questions? Thank you for advocating for yourself. No one else is going to do it. All right, let's do one more, and that's basically it for today. You guys are getting this. Last one. There is no oxygen on the product side, so consider it a non-factor. No change. All right, so Sn is 10. It goes from +2 to +4, so that has been oxidized. And iodine, or iodide, generally the same thing, goes from +5 to -1. So that's going to be reduced. Okay, so let's do our oxidation half reaction first. We have Sn +2 becomes Sn +4, which means it lost 2 electrons. Lost electrons are indicated as products. And then we have iodide is I with a +5 oxidation number. It is going to gain 6 electrons to become iodide with an oxidation number of -1. This is clearly not balanced. We need to get that 2 electrons here bumped up to 6. So here's the idea, everybody. I'm going to give you a visual, if it helps. Here is a tin, here is a tin, and here is a tin. Derek, for every, oops, a little confusing there. Derek, every tin needs to gain, or excuse me, needs to lose 2 electrons. So how many total electrons will that be that are lost? 6. So we can replace that 2 with a 6. So how many tins do we need if each tin is losing 2 electrons? We need 3 for both. That's all you got to do. So put a 3 coefficient in front of both of them, and you're done. There's 3. 1, 2, 3. This guy is going to lose 2. 2 electrons gone. This guy's going to lose 2 electrons, gone. And this guy's going to lose 2 electrons, gone. 2 plus 2 plus 2 is 6. Okay, and that is it. That's the last part.